Have you ever wondered what happens when you put something down the drain? It goes to a wastewater treatment plant. This is true of anything that goes down the drain, including household chemicals. But what happens to these chemicals? We will be covering each major step in the process of water treatment, including preliminary, primary, and secondary treatment, disinfection, and transport. We will also follow the journey of 3 major chemicals and observe how they are removed, or maybe not removed, from the water you put down your drain. To begin, let's explore the main steps involved in the recycling of wastewater.
Preliminary treatment is the act of removing objects through screens to filter them from the water. Things like scraps of fabric, pieces of plastic, and other things that probably shouldn't have been put down the drain at all are removed and then sent to a landfill or dump. In addition, grease is also removed through the process of skimming, which will be explained later in the video. After these preliminary treatments, there is a primary treatment step. This is a tank where solid materials, yes, poop, in the wastewater, settle to the bottom of the tank and water flows over the top.
We then move on to the secondary treatment process, which focuses on the aeration of the wastewater. Aeration means adding oxygen. Thus, the water is moved to large tanks bubbling with added air. This is similar to pumping air into a fish tank, but on a much larger scale. The air is added so that the bacteria can eat or oxidize the biodegradable carbon and ammonia in the waste. The next step is another settling tank like that used in the primary treatment. This time, the goal is to remove the bacteria used to degrade the waste. A portion of the sludge collected is sent back to the secondary treatment step to maintain the community of bacteria that degrade the waste. It's a careful balance.
The last step for the water is chlorine contact basin, giving chlorine time to disinfect the water before it's released. This is similar to the chlorine bleach used as disinfectant in some household cleaners. Another chemical, usually sulfur dioxide gas, is added to remove the chlorine from the water prior to its final release into creeks, rivers, and oceans. We don't want the chlorine to harm the biota living in the river. The sludge collected from the settling tanks is put into a digester tank to reduce its mass, and then it is further processed to remove water. Methane is collected from these tanks and can be used as fuel. The digested sludge is then used as fertilizer on farms, moved to landfill, or even burned. Now that we know how a wastewater treatment plant looks, we can look at which one of these processes leads to the removal of a variety of harmful chemicals that make it down our drain. It is important to know that the treatment process is not designed to remove these chemicals, but it happens to some extent. And some of the chemicals are still released into the environment.
The first way the chemicals are removed is by sticking to the particles that settle during the primary treatment or in the secondary settling tanks. The process for one substance becoming attracted to another is called sorption, which occurs for the chemicals that are hydrophobic, meaning they don't like being in water, where hydro equals water and phobic means fear. An example of this kind of chemical is polycyclic aromatic hydrocarbons, or PAHs for short. PAHs enters the water treatment process through cooking grease or oil, where it is sometimes washed down kitchen sinks after someone finishes cooking. These are removed during the first stage of the treatment by either sticking to particles that settle or during the skimming portion of the process if they are stuck to floating fats and grease.
Additionally, an array of pharmaceuticals are also typically found in wastewater treatment facilities. These get to wastewater treatment facilities because people excrete them after taking their medicines. Another possibility is dumping unused medicines down the toilet, which you should not do. Some of these compounds can be degraded by the bacteria in secondary treatment processes. Because these compounds are at very low concentrations compared to the biodegradable carbon, this degradation is accidental but helpful. Even so, not all pharmaceuticals are removed this way, and the amount in plants varies from 60 to 99%. This means that even if chemicals are degradable, some will be present in the water that is released into the environment. Finally, some of these pharmaceutical chemicals end up evading all facets of the wastewater treatment process. These substances have a low biodegradability rate, and they are very hydrophilic, meaning they dissolve well in water and don't stick to particles. Unfortunately, there are many chemicals like this, and they wind up in our lakes and rivers.
Fine, I'll make it regular.
Okay. At the end of the day, you might ask why all of this is so important. The wastewater treatment is important so you can do this with no worries.